Let's build our own cloud, shall we? Pour some water into a plastic bottle with a third of it empty. Put the lid on and shake the bottle. This allows the air at the top to become saturated with water vapor. Now squeeze it. You're raising the pressure and temperature at the top of the bottle. Let it go. You're reducing the temperature and pressure. But nothing happens. Open the lid, light a match, put it in, put the lid back on and squeeze the bottle. Here's your own cloud. What changed? The matchstick adds tiny smoke particles. You cannot see them, but these smoke particles are condensation nuclei. Without them, water vapor cannot form into water droplets. You can't see the water vapor in the air initially, but squeeze the bottle to raise the pressure and the temperature. When you let it go, the pressure drops, which allows the water to cool and condense. And this will form those tiny droplets, but only if you've got those condensation nuclei added by the smoke. Condensation nuclei are hygroscopic, meaning water seeking, helping them bind with the water vapor to form the clouds we see daily. Water vapor plus air plus condensation nuclei is equal to a cloud. For a cloud to form, air must be rising, expanding, and cooling. Let's go through what happens when a real cloud forms. Step 1. As the sun heats the Earth's surface, any area that heats more rapidly than its surrounding, like an asphalt parking lot on a hot day, can create a bubble of warm air that rises. Step 2. The rising warm air mixes with the cooler, drier air around it to expand. Once the bubble of warm air expands, it cools. This process continues, like in a bowl of noodles when the pot of water circulates as the noodles cook. If more warm air arrives from underneath, the warm air bubble will keep growing until it reaches the saturation point and condenses, making a fluffy little cloud. Now, let's picture a cloud factory. As the heat from the sun starts cloud formation, when a cloud gets too big, it starts to cast a shadow, cutting off the heat from the sun and allowing the ground to cool. As soon as the cloud moves, the sky is clear, the ground reheats, and the cycle repeats. While we're looking at clouds, let us find out what happens inside one. In the growing stages of a cloud, the air on top of the cloud is cooler than below. The water vapor condenses in the cooler regions to form heavy water droplets. These heavy particles don't fall as they are picked up again by the rising hot air. This rising air current inside the cloud is called an updraft. The rain and ice particles surge back up and get bigger as they merge with other specks of moisture, creating a swirling mass of rain and ice within the cloud. There's no rain yet, as the cloud is still in its growth stage. As a cloud matures, raindrops and ice particles get too large to be supported by the updraft and finally start to fall, creating a downdraft within the cloud. Now the cloud has both an updraft and a downdraft. With updraft speeds still over 60 to 70 miles per hour, the turbulence causes friction in the cloud, causing lightning bolts to stab outwards while the cloud moves upwards to the stratosphere. Three things happen here. The downdraft finally reaches the ground as rain or hail. The supply of warm air to the cloud is cut off, stopping the updraft. This leaves a steady downpour to carry the rest of the cloud's moisture to the ground. This blew my mind. The fact that a calm and peaceful cloud from below has so much going on inside it is fascinating. I have something for you to think about. Do you think summer rain is the remaining snow from winter in the clouds that never snowed? Before we go, while we're on the topic of snow, do you know why snow does not destroy soil? It's because snow doesn't conduct heat very well. Dry snow acts as an insulator, protecting plants below its surface by preventing the ground from losing all its warmth and getting too cold. Now we know what makes a cloud and how they form. In a later lesson, we will discuss the different types of clouds and what they mean to us to understand the weather. In our next lesson, we will understand the wind.